Hey, Jakub, how are you?
I'm very well, and you?
Awesome. Well, welcome to the inaugural first ever TechFabric podcast. Today, I've got Jakub Konecki with me. You are a TechFabric employee. Why don't you give a quick intro, and then we'll kind of jump into the discussion.
Sure. I've been in with TechFabric for 4 or 5 years now. I'm an architect working on a number of projects. I've been involved with a lot of different TechFabric clients in different areas. I'm mostly working with .NET, Azure, looking at companies now, projects in different areas, from automotive to banking. Lots of interesting things to do.
All the fun enterprisey things to be working on.
Yeah, from big to small.
Yeah, that's awesome. Well, so today, I wanted to kind of bring this conversation together. We also had Preetham Reddy, who was the founder of TechFabric, who was going to join us. He had a little bit of laryngitis, so we decided to punt that one. But with the backdrop of the Los Angeles fires in the last couple of weeks, what we're seeing is a lot of, it doesn't matter whose fault it was, but there's a lot of finger pointing and a lot of things that have come to light in terms of, not refilling reservoirs or not seeing certain projects through. And it just struck me as, in the work that we do at TechFabric, basically being entrusted with enterprise security, data integrity, and those types of things. There are so many things that we could be doing, and DevOps and security and disaster mitigation is always a trade-off. How much is enough? How much is too much? Where are you wasting money, et cetera? And so I've worked with you on projects in the past. I think you've got a great DevOps mind, systems thinking mind, architectural mind. And so I wanted to just, have a discussion here about maybe some of the things that I've encountered, you've encountered in our past lives, where we've lost data or we've had some, situations like that and lessons learned from all of that. So with that said,
Yeah,
how
of
do
course,
you,
of course.
yeah, have you been following what's been going on out there?
Yes, we've seen all the videos from California. It's incredible, heartbreaking. Literally the whole blocks of houses just gone, and there's nothing left. It's incredibly shocking. People losing everything in a split second, because if you watch how fast the fire was spreading, it was literally seconds, and your whole house was engulfed. There's nothing you could have done once that fire started. You really had to be prepared up front in order to deal with it, because once it's there, it's already too late.
Yeah, it's a great point. There's all these stories of where they were implementing these swimming pool pumps and able to spray down their houses and sort of put out spot fires. And it's frankly a great metaphor for, that sort of disaster preparedness that enterprises can take. Because you think about, if you survived the fire, your life goes on. You will rebuild. It's not as if, your life is over because your house burned down. For a company, though, for an enterprise, that could be the end of the enterprise, a massive data breach, or actually one of my neighbors is he is a high-level security guy for one of the FANG companies. So I won't name who, but he was leading an effort at LAX. He's here in Colorado. He flew out to LAX because there was a lot of security keys, et cetera, that they keep at LAX. And they were trying to figure out how to deal with where to move them to safely, et cetera. So again, the metaphor of sort of, thinking around corners, looking around corners and thinking about how do I protect my enterprise from the unknown? It could be a fire, could be an earthquake, could be a hack, could be, 1,000 things. And so
one thing that you have to remember is that when such a widespread disaster happens, it's not just you who is affected. There will be others in the area. So, you would instantly see all the road blocks with car. You have huge traffic jams because, everyone tries to evacuate at the same time. So you may have a disaster recovery plan that assumes that, the road will be empty. I will just, throw all the suitcases in the back of the car and drive. No, in the real life scenario, that's not going to work like this. So your disaster recovery plans, whatever they are, they have to take into account that others may be affected at the same time. Going back to the corporation scenario, well, you may think that you can move your data over a network, but that network may be congested because everyone else is trying to access their backups that are sitting on some server somewhere, and you can't do it in time. So those are things that you really have to think up front, so you are not caught with your pants down, when the thing happens.
Oh, that's a great point. Yeah, I hadn't even really, frankly, considered that part. So what, I remember, God, years ago, early days of Athlinks, we had a backup that was running at the same time we were doing a bunch of massive index rebuilds. We had just not paid attention to the scheduling of those jobs. And so the rebuilding of the index hosed one of our backups and took the database completely offline. No problem. We thought we'll just restore from the previous day's backup. Turned out the previous day's backup was corrupted. And so for literally 3 white-knuckled days, luckily, Athlinks wasn't to the scale that it is today back then, but I remember I had a Palm Trio that had Windows CE on it, and I was coaching my son's baseball game, logged into one of our servers, just checking the status of a restore, and it was things where something as simple as just having a check on that previous day's restore and making sure that had integrity would have mitigated the entire thing. It wouldn't have been maybe an hour's worth of downtime and jump back up.
Yeah,
right?
Scott Hanselman from Microsoft has a brilliant saying, which I love, that backups always work. It's the restores that fail.
That is brilliant.
You have to test your restores.
Yeah.
And I have a brilliant story about Toy Story 2, the movie. I don't think many people know this story, but it's brilliant, and it highlights all the issues with backups and disaster recovery that you can experience. So we have to go back to previous millennium. It's like 1990s, end of 1990s. Pixar is working on Toy Story 2, and they have like 150 animators, creating all the scenes for the movie, and they had a huge file server that was centrally storing, all the wireframes, all the scenes. It was actually used by another teams in Pixar as well. So there was the central repository. Back then there was no cloud services, no Azure, no broadband really. Everyone was on the dial-up. So they had this central file server that was used by like 400 different animators from different teams. And one day CTO was just in the folder with a Woody character wireframes, and he was refreshing the folder, and he spotted that there are fewer and fewer files. Every time he lists the files, some are gone. And then the whole directory was lost. So he went one directory up and files are just disappearing. So he literally got a phone, called some engineer, in the data center, and told him, run to the data center and literally pull the power plug, from the wall, literally that. And it turned out after the machine, was restarted, that they've lost 90% of the files. So 150 people working for 2 months on a movie, and 90% is gone. Fortunately, they have tape backups. So obviously they went to the tape backups. They restored from the backup. They did some tests on some recent files just to make sure that whatever was recent on the backup is good. They know what the cutoff point is. Everything seemed fine, They said, phew, we've lost a day because it was the previous night's backup. So we've lost a day. Happens, okay, all good. That was on Friday, I think. The following week, people started reporting different issues with animations, like things were not working exactly correctly, they were not rendering correctly, and some of the changes weren't there. And after a week, they've noticed that the file backup was actually overwriting itself. Because the whole movie, the wireframes, they took around like 10 gigabytes of data, and they had only 4 gigabytes on the tape drive. So any new backups were just overwriting previous backups. So when they've restored everything, now you're in the position where you don't really know what is what is latest, what was lost. It was a total disaster because now they don't know what the correct files are.
Right.
And fortunately, I mean, they had like a huge meeting, with like 30 top people saying, what are we going to do? Because we've lost 2 months of work. We can't really recover from it. One of the, I think it was the like creative director who was on a maternity leave, and she said, wait, I have a machine at home. So she was given a Silicon Graphics big machine.
Yeah.
So she could work at home on the movie. And because, back at the days, 56 kilobits, mobile dial-up, you couldn't download 10 gigs over the phone line. So they did the backup of everything on that machine and should use modem dial-up to only download, the latest changes. So she actually had the whole movie on the hard drive at home. So they basically went to her home, got her machine, wrapped it in blankets, and bring it back to the data center.
Drove very slowly.
Yeah, I think that story, highlights all the different aspects. You may have your backups, but they may not work.
Yeah.
And the worst thing that, the most challenging thing is when your backups, they seem to work when you install them, but actually they don't. And the data loss, you can't really recover from it. So you restore the database, and if everything is fine, it's good. But if half of your database is inconsistent, how are you going to recover from it? And that's something that you have to think up front. Now, you may ask, why haven't they noticed that the tape is full and overwriting itself? So they had error logs from the tape backup system. But those error logs were stored on the volume that ran out of the disk space itself. So no new logs were appended to the log file. So it all looked good. But your error logs are wrong as well. So yeah, just a combination of different things that happened at the same time that caused that disaster to happen.
Yeah. Yeah, look, I was writing software in the early 90s when that was, one of Athlinks ran out of drive space, not regularly, but, a couple times a year, where you are sort of in panic mode for about a month thinking, okay, because, we were in at AWS, we were at like rack space, but, you had to basically walk somebody through pulling a server offline, upgrading the hard drives, et cetera. So it wasn't a trivial thing where it is now, where you just provision a larger, set of storage to expand those things. So I'm intimately familiar with that exact thing, where you just, one decision that at the time probably felt preposterous, right? We're never going to run out of a 10 gig or 50 gig or 100 gig, back in the day. First computer I ever owned had a 2 meg hard drive, right? So when you get into, hundreds of gigs and then tera and then petabytes, it's like you think this is never going to fill up, and then lo and behold, a year later you're up against the the ceiling on that.
Yeah, the largest hard drive that I owned was a 212 megabyte Seagate single plate disk in 1990s. I couldn't fill it up back then.
No.
But now, you look at your mobile phone and the size of the photos you take on your phone, and oh my God, you're just losing gigabytes instantly.
Yeah.
we are both engineers with gray beards. We have experience from those olden times before cloud providers, where you had your data center. You had to prepare everything yourself. You have to manage everything yourself. And your disaster recovery had to be done 100% by yourself and cater for all the possible scenarios, like hard drive failure. Fortunately now, when we are working on projects that utilize cloud, there are lots of things that we don't have to worry about.
Right.
I don't think about individual hard drives failing. I'm using storage offered by Amazon, offered by Microsoft, that hides that kind of issues from me. I know I will have 3 copies in one region. I can enable geo redundancy. I have another 3 copies in a totally different physical location. I don't have to worry about it. Power outages, networks, no, that's handled by your cloud provider. And even if you look at a more complex services like SQL databases, you can get hosted SQL database where the backups are managed by Microsoft in Azure, for example. So your disaster recovery, I think now has to be different to what we used to do 20 years ago. We should, in my opinion, move away from the mindset of, well, I need to have a separate data center, prepared. So when my data center A goes offline, I can just route all the traffic to the other data center and I have a copy of everything. With different cloud services, you have sometimes replication built in. You could create a cloud native applications that runs at multiple regions at the same time, spreading the load. So when one data center goes offline, the other data centers just pick up that extra traffic. So there's actually no downtime to you. You don't have to create a hot spare copy of your whole infrastructure and switch to it and be paying for it when it's not used. If you run in multiple data centers, you have your hot spare actually used, taking some of the load, and then that your backup works. Because of all those hot standbys, they should be in sync with your main instance, but there's always some issue that you will discover when you switch to it. So, in my opinion, the best backup is the one that you're actually using all the time, because then you're 100% sure that it works.
Yeah, that's a great point. So that deals with like systemic failure, right? Hard drive, data corruption, et cetera. One of my first company's celeb sites, we had a celebrity directory of fan sites and official sites. And I was pretty new to SQL, and I wrote a SQL statement, and I was updating some information on Brad Pitt. I changed his birth date or something along those lines. And and I moved on with my next task. And a couple minutes later, one of the designers walked into my office and said, "Hey, every celebrity page you go to now says Brad Pitt. Like everybody's name is Brad Pitt." And I said, "Oh, it's probably," and then I realized, oh, wait, I was just doing something. And I looked, and of course I forgot a where clause with the ID, right? And so 2 things came out of that. One, the way that I write SQL now, I write my where clause first, 100% of the time. And any update to data, I always wrap in a transaction without a commit, right? So it changed my entire brain. That one disaster where then we had to restore from a backup, et cetera. So point being here is, in this world now where the sort of the backup and restore thing has been a little bit obfuscated from the daily concern, how do you deal with that where engineers make mistakes, hopefully never in production, but let's face it, it does happen. How do you deal with that, and how do you plan for that? Or is that just something you sort of put on the back burner until it happens and then you deal with it when it does?
Well, I can tell you straight away that I have exactly the same story. I remember when I was very young, one of my first jobs in the investment bank, I was working on the production database, and some older gentleman, DBA, he told me to always wrap your statements with, begin, trans, and rollback, and just make sure that when you run it, the number of records affected is what you expected before you actually commit. And I was doing this, and then I selected the statement without the rollback at the bottom and without the where clause, the part of the where clause. And again, all the records updated in one go. And I had to buy some donuts to DB admins to thank them for a prompt restore. So things will happen in production. Your engineers will modify production because you have to maintain your production environment. You will be making changes and you will be making mistakes. And you just need to acknowledge upfront that those mistakes will happen. And you have to think about two things, in my opinion. One is to have a process to deal with those issues. So if the mistake happens, your engineer will know who to call, how to report it, how to deal with it. We all know how to react to those scenarios. Some scenarios are so common, you can prepare for them upfront. You know what kind of things can go wrong in your system. Just sit down and plan for them. And the second thing is, have you heard about a Swiss cheese model?
No.
So this is a model developed, I think in the 50s or 60s in last century by a psychology professor from University of Manchester in the UK. And it's been adapted in aviation a lot. And I can actually, we can talk about that crash in DC from a couple of days ago, because that model is dealing with how to prevent accidents from happening in the first place. So if you think about the slice of a Swiss cheese, it will have holes. So if you use a single thing to prevent you from bad thing happening, that's not enough, because there's no silver bullet. There's no one thing that will stop mistakes, accidents from happening. Everything will have little holes in it.
Okay.
Your firewall will not be perfect. Your network security groups will not be perfect. Someone must have access to production environment. So you can limit other people, but you still have some engineers who have right access to prod database, for example. So you need multiple slices of cheese. You need multiple barriers. Not a single barrier is perfect, but different barriers will have different types of holes in different places. So think about your car. Well, in order to avoid accidents, we have indicators. You have lights, you have your horn, then you have your seat belts, and you have your airbag. Not one thing will stop all the accidents from happening, but the combination of them makes a fatal accident quite unlikely. And going back to that DC crash, if you listen carefully to what the aviation experts are talking, and when we look at the NTSB report, later on, they will be talking about all the different things that are in place, and they will be talking about that unfortunate situation when all the holes from those different barriers actually aligned, and multiple different things went wrong at the same time. Because there are so many flights every single day around the world, and they all land without any issues, because all those barriers actually work together. So when you're thinking about your system, again, try to think about as many different layers of security, redundancy, different types of backups, different scenarios, because not one thing will stop the bad thing from happening. You need a combination of all of those.
Yeah, it's a great way to look at it. It's sort of those holes all aligning. At some point, 2, 3, 4. Obviously, the more that align at once, the bigger problems can happen. Which kind of leads, culturally, having a culture where people are encouraged, are not afraid to raise their hand and say, I screwed up. Because when you did that update statement, especially in a banking system, every millisecond that it takes for you to raise that, get it to the right person and start that restore is potentially, customers lost, actual money lost, reputational loss, et cetera. And so having that kind of culture of accountability where somebody, because if somebody knows, well, the second I open my mouth, I'm getting fired anyway, I'm going to lunch, if you've got the wrong person, behind that keyboard. Whereas if somebody feels like, okay, I'm going to be rewarded for being the grown up here and making the tough decision, the tough call to go admit what I did, that is just so critical in an organization.
That's really important point you're bringing up, Troy. That person who came up with a Swiss cheese model, his name is James Reason. And he also came up with a concept of a just culture. Basically, he proposed that most of the issues in corporations, most disasters in corporations, are not due to one person, but more related to cultural issues within the organization. And he says that we really should be looking at why things went wrong, know why someone did something or who did that. It's not about the blame game. It's literally about learning from that mistake. Mistakes will happen. We are all sometimes tired, sometimes distracted, and things will happen. So it's all about discovering what went wrong and updating, evolving your processes within the organization to make those things difficult to happen again. So adding another slice of that Swiss cheese that will stop those kind of issues from happening again. And having the culture, like you said, when someone can come up and say, I made this mistake. How can we all make sure that no one else will do it again? And being confident that there will be no repercussions for this person. On contrary, they have to be encouraged that that's what you want from your organization. People flooding up issues. You need to encourage whistleblowers to come up and say that those things are happening. Because if you are on top of your organization, in the boardroom, you don't see what's happening on the floor. You don't have that visibility of what individual engineers are actually doing. They see those issues at the best. So you have to have a process in your organization to encourage and listen to all those concerns.
Yeah, that's great. That's fantastic. So when you're especially, at TechFabric, we have customers. We don't always have as much control as we would like over some of the decisions that we're talking about here. How do you, or what are the ways that when you're dealing with a client to raise those issues up front to say, okay, we have this new project coming in. Here is, do you think about sort of disaster mitigation and things like that up front, in the middle, toward the end, case by case basis? How do you think about risk mitigation when you're architecting a solution?
You really have to start from day one. It is difficult to retrofit those kind of issues later on once you have your architecture in place. And when you are designing the architecture for your system, you take those things into consideration as well. Most of our clients will use some cloud hosting provider, Azure, Amazon. There are so many services and options available in your cloud for your backups, for redundancy, for security. So when you are architecting your system, this is another argument about which service do we use. In most cases, you just need to make sure that whatever you're using, you just configure it correctly. You're using S3 buckets. Okay, security. Is this S3 bucket supposed to be publicly available? Probably not. You don't want everyone to have access to your data. So make sure that you have restrictions in place. you want to have a VNet in most cases, for secure communication between different components. That's part of the architecture, and you have to think about it from day one. Backups. How do we do backups? Do we use a hosted SQL database where those backups are built in and it's literally just configuration for us? We just pay a little extra for storage and Microsoft is managing it. Or do we want to manage those backups ourselves? And if so, what is the process to do that? It's so much easier to have a proper, secured, well-architectured system nowadays. When you use all those services, you don't have to build everything from scratch. It's all out there. You just need to know which tools to use, how to configure them properly, and you can get 80-90% of your job done really, really quickly. So even on smaller projects that may be constrained when it comes to budget or time, you don't have to cut corners. There's so much out there, so many tools that you can really get a proper architecture with that confidence of having your system secured if you think about it upfront. And it's much cheaper to do it properly from the start, rather than, okay, now let's try to add security to my system. Because some of the decisions that were made later may stop you from being able to secure your system easily. So really, you need to work with architects, with administrators that know their stuff from day one. Because I wouldn't rely on being able to add your security or disaster recovery as an afterthought at the end of the project.
Yeah, it's in a way, it's sort of like unit testing or internationalization. It's always this cost up front that you're not willing to pay, thinking, well, we'll add internationalization later when we add another country, when the reality was adding internationalization up front adds 1% of complexity, right? Your strings just have to get translated, do English only to start, but then adding it later is such a massive lift,
Exactly.
And same with unit tests, like trying to test an
application. And then, later on, you ask for the estimate, and someone says, "Well, it will take 2 months to translate everything." And oh my God, now those things don't fit on the screen because we haven't thought about it. So we need to do the redesign of the UI to cater for other languages. It's not just I need a different string. Yeah. Well, in German, the words are much longer than in other languages. So that has to be baked into the designs. And it's so much easier to do it up front, so much cheaper in the long run than trying to refactor it later on.
Yeah, that's a great point. So what, when you're training or mentoring or hiring engineers, you're kicking off projects, you're thinking about retros and grooming sessions and things, how much are you talking to engineers about this along the way or up front and getting out of, it's so easy to get so mired in the specific details of what this button should do on screen, et cetera. Do you sort of leave yourself little notes or, sort of tie a yarn around your finger to remember to discuss some of these things? Or is it at this point just sort of second nature for you?
It is a kind of second nature because, with experience, there comes that understanding, that gut feel of when you're doing something, you have to do it properly. I don't think any, surgeon in the hospital has to remind themselves to wash hands before walking to the operating theater. That's just something that you do. You don't need to have a big note saying, wash your hands. And the same goes with security, with backups, for example. You need a database. You need to think about how will you back up your data. That's natural, and how you do it. That's the other discussion that you can have with the stakeholders. Is the data really necessary? What if we lose it? Will it be a big deal or not? Maybe in the initial phase of the project where you are trying to do your MVP, just get something out to the market, you may not need a hugely complex backup scenario because you're just trying to verify your business idea. But you know what the plan is to extend the system later on and make sure that, that those backups will be there. You know how to do it. You know that it won't affect your overall architecture of the system. You may not do it today, but you know how to do it tomorrow. Security, you have to think about security from day one. Even if it's an MVP, you want your MVP to be secure and proper. Because again, brand damage, even if you're launching a new product, you have your MVP out, you can easily damage your brand, and it's so difficult to recover from it. So you may think you are saving, a couple of grand because you haven't asked your engineers to add some security, a day, 2 days of work. Well, that doesn't pay off in the in the long run. And as I said before, nowadays it's so easy to do it. You don't have to build everything yourself. It's more about sitting down for 5 minutes, pushing your keyboard away, putting your thinking hat on, thinking, what can go wrong? How would we recover in this situation? What would we do if this happens? I'll give you the example of the plain thought that I would do. I have a SQL database. Okay, we need data backups. If we use Azure SQL database hosted, there's the option for the backup. Okay, let's just enable it. 5 minutes, job done. We have our backups, so we can restore those backups later on. Now, do we know how to restore them? Have we done it before? Would the engineer that's working for me know how to do it? If they haven't done it before, let's spend half a day. Give them half a day to practice. Let's write it down. Let's have a checklist of those are the steps. Do a few screenshots. So when they are under pressure, because the system is offline and I need to restore the database right now, they have a clear checklist to go through. Now, will they have access to those backups? Do we need some permissions? Because they may know how to restore them, but if they can't access them, well, that's not good. Then what is my long-term strategy for long-term backups? I may have everything in my Azure subscription, all my storage accounts, my databases, that's fine. But what will happen if I lose access to my Azure subscription? How will I get access to my backups? Maybe I need to do an off-cloud backup and move them to S3 bucket in Amazon. Maybe I will put them on some other storage. Maybe even on my some local server. So even if I lose access to my Azure subscription, I haven't lost my data. And then the other thing that I think a lot of companies forget about when it comes to backups is I may have a data backup. Fine, I have my data. But what about my infrastructure? If I, let's say, lost a data center, lost access to my Azure subscription, I have my backups, but where do I restore them? So being able to provision your whole infrastructure from scratch. So I have a place to restore the data set into, and I can route traffic to my instance is so important. So infrastructure as code, scripted infrastructure can be a lifesaver. It's not just that it's easier for engineers to maintain. Infrastructure as code can be a lifesaver in your disaster recovery scenarios, because now you have a complete restore. You have your infra, you have your data, you can provision your production environment from scratch. So even if I lose everything, even if my whole house burned down, I can rebuild the house and I can take my precious family photos and put it on the mantelpiece again. So
It's great.
I think a lot of companies are forgetting about infrastructure. They do database backups, but they don't have infrastructure backup.
Infrastructure as code. Yeah, that was actually how I met you, was a big Terraform project for a previous client. So yeah, that was, that is, when you first encounter infrastructure as code, it's sort of, maybe it's not hard to see the benefits. It's hard to see all of the benefits because it's additional work, right? You're used to sort of clicky through, the AWS or Azure dashboards and setting up your infrastructure. And you think at the time, well, this is just 5 minutes worth of work. Why do I need to script this? And then when you go next time to create, your staging environment or a second development environment, and you just spin that thing up and you're guaranteed 100%, it's identical to, oh my God, it was such a game changer when I first discovered the, Terraform and things like that. So where do you, it's interesting that you say that, like the documentation is so important, because it's one thing to know, yes, we have backups. Yes, we have a means of restoring, but does anybody on the team know? Did that engineer leave the company that, set this up a year ago? Or where do you typically document those things? Are those in READMEs? Are they in Notion? Are they in Azure?
I would say
all of the above.
Whatever works for your organization, for your project. If you want to use Wiki in DevOps, Azure DevOps, because you're using Azure DevOps for your code deployment, let's put it that. If you have, if you're using GitHub, you have GitHub wikis. If you have your own, SharePoint where the team would store the data, just put it there. Maybe, like you say, a README with the source code, so it's all up to date. You have the history of the changes. Whatever tool is, it really doesn't matter as long as it is somewhere. And then it has to be up to date. It has to be valid. So you need to practice your disaster recovery scenarios, because otherwise all the documentation gets out of date, and then it can cause more harm than good. Because if you restore and you fail to do it properly, you'll end up like this, Pixar Toy Story 2.
Yes.
You've restored, but your data is not valid. You've lost it, because now people have been working for a week, overriding it, making changes, and you just can't recover from this. So on the project, you have to allocate a bit of time to allow the team to perform those actions. But at the end of the day, they are looking after your production system. They are maintaining it. They need some time to get the confidence and expertise to deal with it. If you're running an F1, a sports team, you don't just hire an F1 driver. You have the whole team that supports them, and those guys that can change tires in 2 seconds, during the pit stop, they train every day. They practice and practice and practice, but it's not a lost money. It's not a cost. It's the investment. And I think companies should look into this as an investment into the success of the project, not purely as a cost that you want to cut down because it's unnecessary. You have to change oil in your engine, otherwise your engine will just seize, and then you have to replace the whole engine. So it's not a cost saving, if you skip changing your oil.
I think a critical point there too is you've got to schedule that time. You have to add tickets for doing these things. It's one thing, and I've been part of these meetings 1,000 times in my career, where usually some executive will say, we need to practice our disaster recovery. We need to practice these things. And it's sort of this cloud that's sort of left in the air, but it's not actionable, as opposed to bringing it in, creating stories, add tickets, budget the time, like anything else. The same thing as when you click submit, the form does this. We're going to practice 2 hours of disaster recovery in this sprint or whatever.
And then we can go back to the company culture that we've talked about before. You must have this company culture where the engineering team will be happy to own the system and be responsible for the system. Because if you mandate that, we're doing a quarterly restore exercises, and it's literally just some checkbox on the form, and someone pretends to do it, but they can't actually, they don't actually do it, they don't get that experience, then it won't work. You think you are safe, but in fact you are not. So you have to work on that company culture to be confident that people have the experience, they have the responsibility, they have all the permissions that they need to do their job, and they are encouraged to flag any issues, and they know that whatever issues they raise will be addressed, so they can be confident in maintaining that system in production. You basically need to get your engineering team to care about the system that they are working on. Then you get all the benefits, because people will be eager to learn. You will get that expertise, spread within the team. You don't delegate this to just like one poor bloke who sits in the corner and he's doing all the restores and all the backups, and then he leaves or he's away on holidays, because obviously when things go wrong, they go wrong. So you need to. All of this has to be the integral part of your project.
Yeah, it's interesting. I mean, I've been in part of so many projects, and there's always this conversation at some point that says, okay, what percentage are we going to allocate to tech debt or something along those lines? And it's this arbitrary, 15%. Healthy companies, and I've never seen that work. To me, it's always, you have to draw things to the product. Everybody wants to talk about product. So how do you mix in the conversation around security, resilience, et cetera, relative to the product, and then even tech debt, where it's not just, what does tech debt mean to, it's going to mean something different to everybody. And so you think about, well, it's about upgrading this thing or providing this level of resilience, and you just schedule the work. I think picking this arbitrary percentage of time you're going to spend doing X, whether again it's disaster recovery, tech debt, or whatever, versus just saying, look, we're scheduling this work like other product features. It might be 100% one sprint, 2% the next.
That will vary on the product and on the time, on the phase the product is in, and the percentage doesn't work in the same way as code coverage doesn't work. Mandating 90% code coverage. Well, I may have 90% code coverage, but my unit tests actually not testing anything. They just skim through the code base without actually verifying all the edge cases and all the scenarios. So it's not about the number, it's about the quality. It's great if your product owner understands the importance of security, backups, disaster recovery, and so on and so forth, and they bring this into the sprint work as any other non-functional requirements. Performance, your system must perform. You don't allocate 10% of your time to performance. That is one aspect of your system that has to be met. So having a product owner that appreciates it is really helpful. And talking about technical debt, I don't like the term technical debt, because to a lot of business people, it sounds like something good. It sounds like a debt you get into in order to invest. So that's a debt, I will pay it off. But most of the companies work with debt. That is a part of the normal business process. You want to get into the debt to get the capital in order to invest it. I prefer a term technical drag, because technical debt is something that slows you down every single day. Your engineering team will perform slower and slower the more technical drag you have, because every new feature will take more time because something is not automated.
Yeah.
You must do some manual checks. You have some manual process, and you pay for it every single day. Um, you will have some technical debt/drag on your project.
Yeah. Yeah.
Some of that will be negligible. Some of it can be quite important, and it's always, the question of: do we solve it now? Do we solve it tomorrow? What is the value of this technical debt? Is it slowing us a lot? Is it slowing us just a bit? Do we have the plan to solve it in the future? If it's on your backlog and you know that you will do it in 2 or 3 sprints time, it's fine. You don't have to end up with zero technical debt on your project. And when it comes to things like disaster recovery, that may come a bit later in the project, but it has to be there. All the stakeholders, they have to understand that that's part of what we are doing. When you run your F1 team, you must have your pit crew. There's no question about it. They will spend, probably a few minutes, during the race, changing tires, and that's it. Driver is doing most of the work. Okay, to be honest. But you must have them over there, and it's not something you can cut down on. And during different phases of the project, different things will be more or less important. Things that are dragging you a lot at the beginning of the project, they may not be that important later on. But I'm a huge fan of automation, and the sooner you automate something, the sooner you avoid manual activity, the bigger payoff you get.
Amen.
And again, with all the tools that are available right now, having a nice CI/CD pipelines, scripted infrastructure, nice deployments. You can still have your approvals, you can still have your checks, you can still run your unit test and so on and so forth as part of your release process. But the sooner you automate all of this, the sooner you have your backups running and restores tested, the easier it is later on. And then every new feature that you work on, you can deliver it quicker, and it brings value quicker. So I would always go for, moving all this work and doing it as soon as possible, because then your engineering team is just happier, and they can concentrate on actually, bringing value rather than doing some manual activities that can be easily avoided.
Yeah, that's great. I love the term technical drag. That is, you're right. That is a much more apt, I think, description of what it is you're trying to fix, because there's some technical debt that's not necessarily wrong. It works. It's old. It's maybe, it's not what all the engineers would love to do. Because look, every engineer I've ever hired, within the first 30 days, they always come to me and say, hey, can I rewrite this thing that's in, and it's like, no, it works. Leave it alone. No, we're not touching that. Whereas technical drag, where it's like, listen, we've got, a massive performance gains we're leaving on the table because of this old piece of the system that is a bottleneck or something like that. So I like the term. This has been fantastic. I love this conversation. I could go on for a couple more hours, but where can people find you on the internets there?
LinkedIn, or if you just search for Jakub Konecki on GitHub. I have a few open source projects. Nice. You can find me there.
Awesome. Well, it's been fantastic chatting with you. I'm sure we'll chat more this week on other things. So thanks for joining us.
I had a lot of fun. Thank you for inviting me. Have a lovely rest of your day and a great weekend.
All right. Enjoy the glittery lights of London tonight. Happy Friday.
Thank you. Bye-bye.
Thanks, Jakub. All right.